Ladies and gentlemen, Linux on a laptop. My name is Tim. I'm one of the Kubernetes engineers. I've been with the project more or less from the beginning. I was invited here to talk, but I was given a real challenge. 90 minutes, no problem. 60 minutes, I can do. 30 minutes? So I'm going to count on you guys to wave me on if I start to ramble. I want to talk today a little bit about Kubernetes and about specifically the ways that we build some bits of longevity into Kubernetes, specifically modularity. Oops. Oh. Right. So just for history, anybody who hasn't seen this slide a dozen times already, we've been doing containers in one form or another for about a dozen years. So this gives us a little bit of perspective on what works, what doesn't work. And we've built the system basically 3 times already. So as we build it over the years, we've had a lot of time to accumulate ideas and features into our system. But what we built inside Google is very, very different from what you want. The open source world, the outside world, is a much more diverse place than Google is internally and a lot less controlled. So for Kubernetes, we get to rebuild the whole thing. We got a dozen years times dozens of people. We get to rebuild it from scratch in less than half the time. The chances of us adding all these features that's going to satisfy everybody in this room? Zip. So we said from the very beginning of Kubernetes, we need to build modularity, extensibility, pluggability into the system. They're kind of the same thing, but they're kind of not. So I'm going to talk a bit about different things that we do in our system that make the system more extensible and more adaptable, and hopefully will give us a longer lifetime than a monolithic piece of software would otherwise have. So let's look at the system diagram. This is a very high-level picture of what Kubernetes does. At the top, let's see if I got a mirror laser in here. Yeah. At the top, we've got our wonderful etcd, which is holding all of our data that is used by our API server. We have our scheduler, which talks to our API server. We have our controller manager, which talks to our API server. This is all together. We call this our master. We've got over here our nodes. The kubelet is our primary agent on the nodes. It talks to Docker or to Rocket. We'll get to that. And we have a kube proxy, which does some of our network setup. In the end, you can see the API server is this sort of giant hub in the system. But if we really want to be honest about the system, we have to also talk about the fact that on the master, we're also running kubelet and Docker, and that we've got these other things that run in the cluster that are there to support the cluster. And sometimes, for example, you want to run logging, but do you want to store it to Elasticsearch, or do you want to store it to your cloud provider somewhere? You want to run monitoring. Do you want to store it to Influx, or do you want to store it off to your cloud provider? You've got your load balancer that you need to run in your cluster. Do you want ours? Do you want your own? These are all different ways that you can plug the system together. Oh, let's not forget about UIs and dashboards. So you get the point, right? This is sort of a complicated diagram, and I'm leaving out about half of it, right? I just didn't have enough space to fit on the screen. So you get the point. I want to talk about all those different components and sort of the module boundaries of them. Kubernetes is a loosely coupled system from the beginning. This is a goal everywhere in what we do. Highly coupled systems are very brittle. They tend to break. So we wanted to keep it simple. We wanted to stay with very loose coupling throughout all of our different layers of the API, through all of our different components. You can see this reflected in a bunch of different places in the system. It also lets you isolate risk, because 5 years from now, if etcd is no longer viable, or if our controller manager has just grown too monolithic and cumbersome, you can replace these individual components without risking the whole system. Sometimes Kubernetes gets accused of having too many interchangeable parts, but we do this on purpose. And most of these parts are trivial to replace. The APIs are very simple. The result of this is that we're going to get a more adaptable, robust system. So I'm going to go back to this diagram, and I want to talk a little bit about the different pieces that are composable. So the first one is a cloud provider. Cloud provider is our abstraction over what environment you're running in. So we have abstractions that are built in for things like Google Cloud, for things like Amazon, for things like OpenStack and Rackspace, vSphere. We're adding to this list all the time. This gives us, right now the cloud provider is linked as a library. We have an open issue to figure out how to undo that, to make it more pluggable, so that when you're running on-prem, you don't want to rebuild Kubernetes, you want to be able to plug in on the fly. So we're working on that. We provide things for interfaces for things like availability zones. What zone is this node in? How do I balance across those zones? For things like identifying VMs and getting names and addresses. For things like creating load balancers. This is currently in use by our controller manager, by our admission controllers, by the kubelet, by a bunch of different things. This is a very commonly used shared library within our system. So fundamental abstraction number 1. Number 2. Kubelet Docker. Let's talk about the runtime. So, as was just mentioned, not all runtimes are Docker runtimes. Not all containers are Docker containers. So we've implemented a new API, it's introduced in 1.2, it'll hopefully be more stable in 1.3, that is called runtime. And runtime gives you an abstraction over what's actually happening underneath. The first and most supported runtime is Docker. The second runtime that we're working on right now is Rocket. Hopefully, knock on wood, it will be done in the 1.3 timeframe, which means you will be able to bring up your Kubernetes clusters with Rocket running instead of Docker. This gives you a lot more freedom of choice as a consumer of how you want to run your containers, how you want to build your containers. Currently, the Runtime API is linked as a library. We are considering and working out how to do an out-of-process version of the runtime so you don't have to rebuild the system to get a new runtime. Also in development is a system called Hyper. If anybody's heard of Hyper, it's a more VM-centric container abstraction. It gives you something that engages the VM hardware, that gives you a little bit more security and isolation between containers, but it's a little bit more heavyweight, right? So it's a little further on this spectrum of containers or native to virtualized, right? So the next API abstraction is our scheduler, right? We get asked all the time, how do I make the scheduler do this? How do I make it do that? How do I add affinity? How do I add rack topological rules? People have crazy ideas of what they want to do with scheduling, especially when you get into enterprises, right? Once you get into an enterprise where people have built out hardware the way that they've built it out, they want to be able to schedule to these things. The scheduler, fundamentally, in Kubernetes is just a program that uses our API. So anybody here could write their own scheduler. It's not very difficult. In fact, the wonderful Kelsey Hightower's newest set of workshops is bringing up a Kubernetes cluster without a scheduler and making you be the scheduler. So you get a sense of what the scheduler is actually doing. It's really not that complicated. The fun part is in the logic of making the decision. So if you don't like what we're doing with scheduling, you can provide your own. And in fact, we now provide the ability to do multi-scheduler within a single cluster. This means that you can write a scheduler that handles only the pods that you care about, only the things that are important to you that need special attention. You can handle them yourself. Everything else you can let flow through the default scheduler. So the fun here now is you've got complete control over what's happening. You can turn it off. You can start your own scheduler. You can run as many schedulers as you want. You can buy third-party schedulers. You can build batch-specific schedulers. You can buy topological schedulers that say only put one of these jobs per rack, which is a real request that has come to us. You can build this however you want. And you can leave us alone. You don't have to put us in between you and your finish line, right? This is one of the big goals here. The next abstraction to talk about is Kubelet itself. Kubelet builds in a couple of different abstractions into the system. So the first one is network plugins. This is something that we introduced in 1.0, but it was very experimental. We've completely retooled it through the process of 1.1 and 1.2. We're working on it more in 1.3. We're using the CNI specification, which is provided by our good friends at CoreOS as part of the AppC framework. It is a really simple, elegant interface that lets us hand control off to a third party that wants to set up the network however they want. The truth about networks is every single network is a snowflake. They're all different. No two are alike. Everybody in this room has a network that has bought somewhere between thousands and millions of dollars worth of gear, and the combination of that gear plus all the software that you run plus all the policies in your organization make you different from every other person in this room, unless you work at the same place. CNI lets us say, I don't want to learn that. I don't want to understand it. You do it, right? Here's a really simple interface. You can write CNI programs, CNI plugins in shell scripts, and in fact, people have done it. There's one checked in one of our example trees of literally writing it as a shell script. So whatever you need to do to set up your own crazy network, you're totally free to do. We don't use Docker's libnetwork right now. And I won't get into why because we'd be here for the next hour, but we can defer to Docker. So if you have a Docker environment that you like and that it works, you can just hand off the networking and let Docker set it up. Likewise, for any other runtime, if the networking just works, you can ask us to take our hands off it, and we'll just use whatever's there. This now gives you, as a cluster administrator, the ability to really tweak, customize, set up your cluster how you want to set it up. The second abstraction that we offer through Kubelet is that of storage. Now, anybody here, quick show of hands, tried to set up containers and ran into the brick wall that is storage? That's surprisingly few hands. Usually the first question we get from people once they get containers up and running is, but what do I do with my data? How do I save my data? Where do I put it, right? So Kubernetes introduced this abstraction of volumes, and volumes then grew into a persistent volume abstraction. Persistent volumes give you some guarantees about lifetime. But the fun part is, what do I actually do with it? I've got these abstractions, but where do I put my data, right? I want to store my data. I'm in Google Cloud, so I want to store it in a Google persistent disk. Or I'm in Amazon, I want to store it on EBS. Or I have an NFS server. Why can't I put my data on my NFS server? Well, you totally can, right? Except now, you've built your application to understand that I'm running in Google Cloud, or I'm running in Amazon, or I'm running in my on-prem where I've got my NFS, or iSCSI, or Ceph, or Gluster, or the 15 other ones that we support. And we didn't like that. We don't want people building to this idea of what environment you're running in, so we added more plugins. And here's a place where you can extend it to add new plugins. It is, again, this is sort of a built-in API. Each of the plugins they support multiple facets of API. So we have things like attach and detach for systems like Amazon EBS or Google Persistent Disk. We have interfaces mount and unmount is sort of a very basic interface. We have interfaces for soon provision and release, which will automatically provision volumes for you on the fly as you need them. And by breaking out these different facets, we give plugins the ability to implement the parts that they need and not the parts that they don't need. Right? So this is one of the really nice things about coding in Go is it's very easy to detect support for these sorts of things. We also have an out-of-process plugin called Flex, which is contributed by community. Yay, community. The Flex plugin lets you drop an arbitrary binary onto the system. We will call it with a particular command line interface at the mount option, at the time of mount, and you then do, again, whatever you need to do. This is an awesome way for you who has some custom bespoke thing that we don't support yet to write your own system, to work it out, to try it out. If you're a storage vendor, any storage vendors in the room? Good. If you're a storage vendor, you can try your crazy ideas here before you send us a bad patch. Then, once you've got it all working, then we can talk, right? This is a really nice escape hatch. We want to build this same sort of escape hatch into more of our plugin systems. So right now we've got about 20, I think it's 19 actually, plugins in our tree. This includes things like NFS and AWS and GCE, but it also includes a few of the magic volumes that we've got, which are things like secrets, things like config maps, things like downward API, that give you facets of our Kubernetes API and project them as files into your file system, which lets you, again, decouple from Kubernetes. You don't need to talk to our APIs directly. You can read from a file. Anybody can read from a file or from an environment variable, right? So next up, load balancing. This is my favorite topic of the year. Something that I knew nothing about 8 months ago, and now I feel pretty well versed in, and I never really wanted to know. Load balancing is something that everybody has an opinion about, especially when you start talking about L7 HTTP, specifically load balancing. There is a wide array of products in the market that do various forms of load balancing or reverse proxying. They all come with a wide array of features that are really wonderful. Most of what Kubernetes today talks about in terms of services is at the L3, L4 layer. All we care about is an IP address and a port. Right? That is not sufficient for what a lot of people want to do. It turns out all the world really is HTTP, or at least the vast majority of it. So we heard the cry from users that we needed HTTP support, so we've added this idea called Ingress. And what Ingress is a generic L7 load balancer API. It lets you describe things like a map of host names and URL paths into Kubernetes services on the back end. What's beautiful about it is that we don't implement anything. It's the easiest thing in the world to write. It's just an API. Then we implement it in terms of the backend, right? So there is an HTTP ingress for GCE, using GCE's load balancer. There's one for Nginx, contributed by the Nginx folks, I believe. There is an HA proxy one that's in development. There's an Amazon one in development, and at least a half dozen other ones that people have come up with that people are developing to this ingress API. The beauty of it here is you can, as a developer, code to the ingress API, write your application using ingress. And you don't need to care what is actually servicing your ingress in this cluster. If you deploy into GCE, you get a GCE load balancer. If you deploy into Amazon, you'll get an Amazon load balancer. If you deploy on-prem, hopefully your administrator has set up something like Nginx, which will give you an Nginx-based load balancer. If you have an F5 in your enterprise, then you could have an F5 deployment by simply writing a controller that reads from our API and writes to the F5 and synchronizes, which is literally exactly the same thing that we're doing with all of the built-in ones. So this is, again, another place where you, the user of Kubernetes, are decoupled from the core system. I don't want you to understand what's going on inside the system, and I don't want you to know what platform you're running on, because that is coupling, and I really dislike coupling if you haven't figured that out by now. In the 1.2 release, we added SSL support. It was a little embarrassing that we didn't have it out the door. We have SSL support now. We are still looking at new features for it. We've had a lot of pressure to add things like TCP plus TLS, which isn't HTTP strictly, but is similar in a lot of concepts. So we're leaving it in beta right now while we figure out some of these other concepts. But it is completely stable and available for use right now. Next abstraction to talk about. Let's see how we're for time. Our Kubernetes API server itself. So one of the things people want to do is they want to add new stuff to the API. We've provided with Kubernetes a unified API concept where all of the APIs sort of work the same. They have the same basic verbs that work across them. We have some form of polymorphism. We let you manage objects in a consistent way. That's really attractive to a lot of people. Everybody has ideas. They have things they want to develop, things they want to push into Kubernetes. We've added a concept called the third-party resource. This lets you, the end developer, build your idea, again, without putting me in between you and your finish line. Because I'm so backlogged on PRs right now, you got about a month before I'm going to review yours. So you can do your work without getting without having me in your way, rather. What it lets you do is store your objects as JSON in our API. It's basically create, read, update, destroy operations. You are responsible for feeding it valid data and acting on that data by writing a control loop. It creates, by writing a third-party resource, you create a new kind in our API. Kind is our magic word for top-level type. And it's treated just like any other kind in our API in that it's managed, it's stored, it's updated, all in the same technique. This really lets you experiment, try out new ideas, or even build out third-party products. You could use this to build products. As an example, we use this as the basis of prototyping our network policy object, which the network SIG has been working on for the last few months. Everybody developed against this third-party API until we ended up with an object that we're all really happy with, and now we're pushing for it to become a real object in the Kubernetes API. Also coming soon are federated API servers, not to be confused with Kubernetes, which is federated clusters. This is the idea that you can have multiple API servers running inside your cluster, and each API server serves a sub-portion of the API space. This is third-party resources on steroids. Because third-party resources is only CRUD, this lets you actually do validation, error checking, building in things like referential integrity, all into your own API server. You can provide whatever deeper semantics you want, and we will defer to you. As long as you're following our guidelines and you've registered with our API server, you are now a seamless extension of the Kubernetes API, again, without putting me in between you and the finish line. This is such a cool trick. I'm really excited about it. So let's talk about networking, because it keeps coming back. No matter what I do, I can't get away from it. So anybody here who's played with Kubernetes run into trouble with services? We couldn't get them to work for some reason or another? Yeah, there's always a couple. So out of the box, we have an implementation of services, right? And service virtual IPs. And it's built on an abstraction that we've built internally around IP tables. We know that it is not the perfect implementation. It doesn't work in every particular case, especially when you combine this with things like network plugins. These two things, they really sort of need to be in sync with each other. But the good news, services are just an abstraction. The abstraction is a virtual IP, and that's really it. People tend to see our implementation of IP tables and they think, well, this is how it has to be done. But it's not. It's just an implementation of that interface. If you want to replace that interface with something else, you totally can, right? So people have already replaced our service IP implementation with things that are based out of their SDNs. They've replaced them with real virtual IPs using the VRRP. They've built around real load balancers, like actually having a load balancing node or nodes in their cluster. I want to see what more people are going to do with this, right? I want people to turn off kubeproxy and do their own thing, and I want to see what sort of creative ideas they're going to come up with. I was discussing just this weekend a way of using straight up Linux routing instead of virtual IPs if you have like an L2 segment that will let you do this. Right? I want to hear more ideas about what people can do here. So past me predicts that I'm running out of time. I'm actually a little ahead right now, which is great. Usually I'm way behind. So I want to talk just about the last few topics. Throw them out. And then if there's any, I don't know if we're going to do Q&A in these sessions, but if people have questions, I would love to take them. So things I didn't get to talk about today. API server, we have authorization plugins. We have authentication plugins. We have admission control plugins. These lets you do things like, obviously, auth and authz are pretty obvious. Admission control gives you a hook as objects come into our API to either accept or reject them or to modify them on their way through, so apply policies and those sorts of things. In our scheduler, we have this idea of predicates and priorities, which you can build into the scheduler as very simple plugins. And then extenders are out-of-process extensions to adding new sort of policies to the scheduler. If you want to use our scheduler instead of writing your own, you can then configure these things through a JSON file or a YAML file, which the scheduler will slurp up and will then retune its priority scheduling. We also have our API server. So the idea of where we store our objects is actually an API plugin. We don't have a second implementation yet, and you all know what happens when you don't have a second implementation. So it is ready for somebody to implement the second version of this. A lot of people have come by asking for, can I use a different backend? It's ready, it's there. We think the abstraction is complete. I want somebody to code against it. With respect to kubelet, we have things like credential providers, which lets you use things like the built-in registries in Amazon or in Google, and Kubernetes knows how to figure out what the credentials are for that different registry. We also have our DNS server, which is an implementation of DNS of a particular schema, but it itself is replaceable, and people have thrown it away and built their own DNS servers or used corporate DNS servers or whatever else they're already using instead of ours. That's totally okay. It's just an implementation of the API. We have logging and monitoring, right? Everybody here has logging and monitoring. Anybody not have a logging or monitoring solution? Yeah, I don't. Right. So does anybody not have a favorite logging, or at least bad logging solution, right? Everybody has one that they like. They don't necessarily want to use the ones that we've built. We can't support everybody out of the box. So this is clearly just an implementation of a very rough interface that says, I want to do logging on this cluster. You get to figure out what you want to do with it, plug it in, turn ours off, and completely replace those. So I always end all of my presentations with this. Kubernetes is an open system. We are open to ideas. We are open for conversation. We do all of our work in GitHub in the public. I want to hear what you guys are doing with it. I want to hear if we're not modular enough for you, if you need a hook somewhere. These are the things that we need to hear directly from end users. So please, if you're using the system, if you're trying the system and you're frustrated because you can't customize it in some particular way that you really need to, I want to hear about it. So whatever, I won't go back to the beginning. My GitHub is thockin. My email is thockin. My Twitter is thockin. You might notice a pattern. You can find me all over the web. Please come and talk to me. I'll be around today. I'll be talking to people here and out in the gallery. I just want to hear from people. So I'll turn it over for questions at this point.
So does AWS use the Google MATLAB technology? Ingress is the Google maglev technology?
Does Ingress use the Google maglev technology? So you must have read the maglev paper. The maglev technology is an L4 technology. So our default service load balancer is maglev. The L7 technology goes through Google front end. Other questions? Come on.
You mentioned that there's a lot of community contributions for like Ingress and how they're kind of like based on like HA proxy or Nginx. Have you seen like any problems with like scaling how like to dynamically reconfigure these systems? Oftentimes it's like templating a config file and reloading.
Yes.
Is it generally working pretty well for that?
So just if I can repeat the question, have we seen any problems with these various L7 balancers doing their dynamic reloads? So what we're doing with containers, like in general, not just with respect to L7, is pushing the bounds of what a lot of software was expecting, right? We're configuring your load balancers much more frequently than perhaps they were expecting to be configured. I know this is true when we go to our cloud APIs and we talk to these people and I say, I want to update this API once every 5 seconds. And they say, you what? Don't do that. It takes 5 seconds to do. We're pushing the boundaries of these things. There are issues, right? Some of these things do need, you write a config file and you send a sig hup and then the process has to actually stop and reload its whole thing. But you can see the evolution of these softwares as they're adding sockets that let them do real-time updates and removes of objects that they're managing. So I think that this is actually a really exciting time for some of this software to sort of grow into cloud native. I know HA Proxy's got this support now. I believe Nginx has something very similar. So more dynamic is becoming the way things are going to work. APIs are going to be forced to be faster. These people who provide, I keep wanting to say companies, but they're not companies. The people who are providing these implementations need to start thinking about latency of their APIs and thinking in terms of SLAs, of like, what am I actually offering you in terms of guarantees, right? Which is, I think, a great thing for the industry.
Hey, this presentation was all about the modularity and accepting the third-party code to Kubernetes. I'm wondering if there's any process that takes me from me writing a feature to have it ending up in a particular release of Kubernetes. I know technically it's a pull request, but what do you guys use to promote features into the releases? What's the scoping process for each release?
So this is something that we're working on clarifying right now. There is sort of a structure that's sort of informally defined right now. The structure is basically we have an alpha definition, we have a beta definition, we have a GA definition, right? And this is the cycle any feature has to move through. Very, very rarely we'll move something from alpha to GA or from concept to beta and skip a stage, but it's pretty rare. The process really does start with a proposal. Tell us what you want to do. It depends on how big the idea is. If it's a very small feature, maybe you skip the proposal stage. But generally, you start with a proposal of, I think you're missing feature X, and I would like to implement it, and here's a rough sketch of how I think the implementation should work, and here's the problems that it's solving, sort of a PRD cross with idea. We move from that proposal into a pull request. If that touches the API, you're going to get beat up at least a couple times on getting into sort of the API semantics right. We have a very consistent, or we try to have a very consistent API, so it's very important. But really, it's a development-driven process. Like, as your development gets more robust, we move you through the phases. So if you come in with a crazy idea and it's really unproven and we're not sure whether you've got the API right or not, we're going to start it in alpha, right? So as an example, in the 1.3 cycle, we will have this idea called pet set, which helps you run systems like etcd or like Zookeeper on top of Kubernetes. We really are not sure that we've got the API right, so it's probably going to start in alpha in 1.3. We took something like config map, which we developed through the 1.2 cycle, and we were pretty confident that the API was right, and there really, I mean, this is a map of string to string. It was pretty hard to screw up. And that the implementation was simple enough that we just sort of skipped straight to GA, but that's really the exception and not the rule. So I think I saw Sarah back there sort of smiling. One of the things that we're working on is documenting this process of how you go from an idea to a commit more clearly. Over here? They're coming.
Thank you, Tim. I think the integration with Rocket and Kubernetes in 1.3 is very important for the way that I would like to live. What does it mean Rocket support will be ready in Kubernetes 1.3, knock on wood?
It's really about the sort of the race for our development tree. So we have a rough cadence for releases, and the cadence is about every 3 months. We're coming to the end of that development cycle. So we take our 3-month cycle, we back count a number of weeks for stabilization and documentation and testing and other things. We're coming up soon on the end of that development window. Rocket, I think you said, is like 92% passing EDE, which is fantastic. If it makes it to 95%, I don't know if we've set a clear metric for like what is in. If it hits some metric, then we decide like it's going in and it's going to be stable. We're not going to hold the release for Rocket, probably. Right? I don't think that we've defined Rocket as an absolutely must-have blocker stop ship feature, but that really comes down to product management. If it's in, then it's supported, and if it's not, then unfortunately we'll have missed the train, and the next train will be along in a couple of months. Is really all I mean. 1.3 is due out end of June, early July. So we really are coming up on the end of that window. It's like on the order of 2 weeks left of development time. So I'm going to cut it off now. If anybody has more questions, I'm happy to take them outside. I'm being told that I have to get off the damn stage. So.